Hello and welcome everyone. In this video, we will review what a series data structure looks like in Pandas library. And as we have seen in the previous video, a series is used to model one-dimensional data similar to a list in Python. In addition, the series object has an index and a name. Because a series is one-dimensional, it has a single axis represented by the index. So let's look at an example where we have a dummy data of number of songs by different artists. So in this table, there are two columns. One is the artist column where values range from 0 to 3, and then data column which represents the corresponding number of songs for that individual artist. In Python, a possible equivalent data structure for this series is a dictionary, which should contain list of data points, indices, and also an entry for the name of the data. So here we are creating this dat variable, which is a dictionary, and the keys in this dictionary are name, index, and data, and the values corresponding to these are the name of this dictionary or table, and then we have the indices as list, and then we have the corresponding data, which is the number of songs for that individual artist. So let's run this cell, and next we will see how we can pull items out of this data structure. And for that we have written this function which is get underscore item. So it takes this dat dictionary, and then we provide an index value here, and then the way it works that for that index value we find where in index list that index value appears, and once we have that value index, we retrieve the corresponding data out of this dictionary. So let's run this cell as well. And now if we test this function and get underscore item for an index value of 2, we should be able to see the answer as 38. And if we run this cell, we get 38, and we could confirm it here in cell 1 that the number of songs for the artist labeled as 2 is 38. So in series data structure, index don't have to be of type integer. This data structure also supports other index types such as strings and dates, and even duplicate indices are allowed in series in pandas. So one reason of writing this double abstraction is to address this issue as well. So even if we have index values that are not of integer type, we should still be able to retrieve the corresponding data using this get underscore item function. So let's see for that. We created this that variable, so this is updated now. Here index values are a list of strings as compared to integers, whereas the data remains the same. So we run this cell and try to retrieve the number of songs for the artist Zain, and again, like, we should be able to see the songs corresponding to Zain are 38 songs. So many of the operations that we perform on a series, they operate directly on the index or by index lookup. Um, so in pandas, what we could do, we first import pandas as PD, and that's what we saw in the previous video as well. For creating a series, we could create the same series like this. So we have a songs series, and we start with pd dot series, and then we provide the data as a list, and which is the total number of songs, and then we have the name of the series. We also have the artist names provided as a list in the index. So if we run this cell now, so we could see that we have a nice series, nicely formatted when it gets printed. So we see in the first left column the name of the artist, and then we have the songs written by those artists in the right column, and then we have a name of the series and also the data type for the data stored. So the series can hold strings, floats, booleans, and other arbitrary Python objects. So there is no requirement for a series to hold homogeneous data type. However, to get the best speed through vectorized operations, it is important that values are of the same type. But again, like it is not required, series can have heterogeneous data types as well. So let's inspect the index of the series. So we could inspect the index using songs.index. And here we see the index of that series, and since it's a list of strings, so we see the data type as object. So the default value for an index are monotonically increasing integers. The object data types can also be used for strings and also for heterogeneous data types. Now, how does a series deal with not a number value or an n value? So for a missing numerical value, or when pandas fail to find a numeric representation of an entry, it uses nan. So this is similar to null in SQL and is ignored in arithmetic operations in pandas. So if we have a nan series, so we again like created this series with pd.series, and then we provided a list. So in this case, we didn't bother to add the index and also the name. So we have a missing value as none, and if we run this cell, we can see that this none has been changed to nan value, and the data type is float 64 now. So that's the only data type that supports nan value. So even if the other value was integer, we are still storing it as float 64. So pandas in its arithmetic calculations, as we have seen before, here it ignores the nan value. So if we want to count the number of values in this series, so we could use the count method here. So nan series dot count, and then we can see that there is only one finite value in this series. So this also has a lot of similarity with NumPy because the series objects behave similarly to a NumPy array. We could do broadcasting, and we could use all these methods that we are used to using in NumPy. So we could create masks as well. So for example, here we want the songs that are greater than the median value. So we could create this Boolean array of masks representing only those songs that are greater than the median value for the entire series. And then we could use this Boolean array or mask to filter the data out. So when we write the code like this, so we only retrieve the values that are true here. So in this case, we can see that song masks. So we should only be seeing Paul and Sinatra songs now. So yeah, so we could do a lot of things in pandas and with series, and we will keep learning about those in the next few videos. So please keep watching, and see you in the next video.